Hello and welcome to Func Prog Sweden. First, as always, I would like to thank all our recurring viewers. Welcome back to Func Prog Sweden. And to all new viewers and participants, welcome to Func Prog Sweden. This is the meetup where we explore functional programming. And we have had presentations in anything and everything from, believe it or not, C++, Java, Erlang, Haskell, Scala, Clojure, Rust, Dart, and more. And it doesn't matter if you're a functional programming expert or if you have never heard about it. You're warm welcome, and hopefully we'll learn something new today. With that said, let's head over to the agenda for today. First up, I'll do a short introduction by me, Magnus, and then we'll head over to Catch 'em All, Efficient Massive Tabular Data Handling with Tablecloth by Mey. After that, we go over to Rustland, an intro to Rust by Michael. And in the end, we'll head over to Darklang, a functional language for the cloud by Paul. And of course, as always, I'll do a short summary in the end. First up, I would like to thank our video sponsor, Adabeat. Adabeat is an IT consultancy company based in Stockholm, which have offices in Stockholm and Ho Chi Minh. And most of the developers have a functional programming background. If you want to know more about Adabeat, check them out in social media or on their webpage, adabeat.com. Then schedule the coming next meetup will be 18th of April, and then we'll run one in May and then one in June, which we haven't really put out any schedule for yet, so we'll come back with that. Then if you want to support the Func Prog Sweden community, head over to Meetup and join the community, or follow us on the YouTube channel. And as of from January this year, we started up a Discord server, so check it out also and chat with other functional programmers. And if you really want to support the community, you can get a t-shirt like this in the Func Prog Sweden spread shop, so you can check out the link there. If you have questions during the presentations, please ask them in the YouTube chat or on the Discord server, and I will read them up to the presenters. With that said, let's get started and head over to our first presentation, Catch 'em All.
Yeah, I am super happy to be here. I am recording all the way from Israel, so cool. Okay, so hi everyone. I am super excited about this meetup, and I'm so happy to have you all here. And let's begin. But one more thing before I actually start. Let me just do this. Okay. Yeah, so remember that this is a recorded session. So in case you missed something or you want to rewatch it again, the link will be available after this recording. And you can see I think in all of the slides, you will see my Twitter handle. That's not to get me famous. It's so it will be easy for you to reach out to me and ask more questions, or you can send me amazing Star Wars meme. That's always coming in welcomed. So 100 billions events per day. So when I worked at AppsFlyer, today I work at Forder as a DevOps engineer, but when I worked at AppsFlyer as backend developer, I had to do, or not alone, obviously, there were other developers there, but I had to handle 100 billion events per day and do massive data manipulation. And then I found, and the main development language was Clojure. And the reason for AppsFlyer choosing to work with Clojure as the main development language was the performance that Clojure brings with it. Now, here's the thing. When you get to a certain extent of performance of events, of number of events that you need to handle, this performance doesn't come just like this out of the box. You have to do some manipulation, you have to tweak some things, and then you start to do some profiling of your code, and you ask yourself, how much time is spent in each function of the code? When does a thread wait on a lock? How much time does a certain thread or function spend on the CPU? So once you start to explore your code and look for the most, consuming parts, then you understand that, okay, you need to do each and every part better, so it's going to take a lot of work. So when I encountered Tablecloth and what it has to offer, my mind was blown away. I am not a part of AppsFlyer anymore, but if I knew about Tablecloth back then, I would be stunned. So I think it's a good time to start. Yeah. All right. Let me present myself because that's important. So wait a minute, why is this getting stuck? Okay, so my name is Mey Beisaron. I'm a software engineer. I am a DevOps engineer at Forder, and I'm writing in Clojure, Node.js, Groovy, Python, and literally any language that you bring up to my hands, I will say, yeah, I want to do it. I am an international public speaker. I do live coding. I do hands-on workshops. And the reason for the international part is because I love to do that wherever I'm invited to. I love traveling. So there you have it. Last thing is that I'm a sworn Star Wars fan. You can see the BB-8 rolling in the side, and that will be the last Star Wars thing in this presentation because we are in a Pokemon theme for today. So okay, let's talk about the agenda that we have. So the first thing that we will do is we will do a small introduction into Tablecloth. We will talk about what this library has to offer in terms of handling tabular data. And then we will talk about the Pokémon datasets, which I used for the code examples that we will see today. Then I will be comparing the same things that I can do in Tablecloth to other ways that I can do that in Clojure. And the last thing that we will do is we will take a deep dive into Tablecloth's main structures. So it will be helpful for us to better understand the way that Tablecloth works and how it's doing its magic. So let's begin with Intro to Tablecloth. So before I talk about Tablecloth, I have to start by presenting TechML dataset because Tablecloth is essentially a wrapper around TechML dataset. Now, TechML dataset was authored by Chris Nurenberger, and it is a Clojure library aimed for tabular data processing, just like Python's pandas, if you're familiar with it, or R's data.table. It supports pragmatic data-intensive work on the JVM by providing powerful abstractions. Now, as I said, the main goal of TechML dataset is efficiency and high performance, and there's a lot to say about this. And if you want to hear more from Chris himself, the author of TechML dataset, I highly recommend this talk that is presented over here. And you can see the QR code that if you point your phone directly at this slide, this QR code will take you to the link of this talk. And while you take this photo with of the QR code, I will say that I could have chosen a better screenshot of Chris's face, but I tried my hardest, and after a few times, I was like, okay, that's the way it is, and I send my love to Chris anyway. Okay, so let's talk about Tablecloth. As I said, Tablecloth is a wrapper around TechML dataset, but what is it exactly? So it's a Clojure library designed to make table processing performant, easy, and consistent. And this library was authored by GenerateMe, which is the GitHub handle of Tomasz, together with the Cyclosh community members who are still contributing to Tablecloth until this very day. Now, if we take a closer look at what I wrote here, when I said performant, easy, and consistent, then I want to say why I chose these specific words. So when you consider technical tools or library, I guess that you should always have in mind a few things, like memory usage, performance, is it cost effective, and developer enablement. And when I say developer enablement, I mean how much human time is invested in getting things done. Is it easy to use? So when I say performant, I mean both developer enablement, this is the kind of performance, and also performance as we all know. And I can assure you that Tablecloth provides both, but you know what? Don't take my word for it. Let's just see that in the next few slides. So, as I promised, we're going now into the Pokemon datasets. So, play with Pokemon datasets. We have for today 2 datasets that we're going to play with. Again, this QR code will lead you directly to the link of those datasets. So the first one, both, by the way, were taken from Kaggle, as I suggested here. The first one is the complete Pokemon dataset. Now, this dataset contains information on all 802 Pokemons from all 7 generations. Now, if I tell you the truth, I'm only very familiar with the Pokemons from the first generation. Don't ask me how old I am, but I welcome all of the 802 because, you know, it makes things much more interesting when you're trying to play with data. And this data set contains just Pokedex ID, height, weight, classifications, etc. The next dataset that we have here is the combats dataset. It contains information on on Pokemon battles with the 2 Pokemons who participated in this battle and the winner Pokemon. Now, disclaimer, I don't know when or where these battles taken place at or when, but does it matter? I don't think so. Let's just have fun. Okay, so now what we will be doing is we're going to compare things that we can do Tablecloth to other ways to do the same exact thing in Clojure. Now, what I'm going to show you are simple actions that are kind of something that people do on their everyday job if they're handling data, like loading a CSV file and then using that as a map, like sorting. And the code that I'm going to show you in Clojure, maybe it's not the best code ever written in Clojure. Maybe you yourself can write it even better or nicer. But I want you to not focus on, the length or the way I wrote it and say, oh, I can do this better. I just want you to take the bigger picture and try to understand what these examples are here for. And let's just take a look and you'll see what I'm talking about. So the first example is how do we load a CSV file and then use it as a map? So we'll start with Tablecloth. That's it. Surprise! It's just one function that takes the file path of your CSV file, and then what you will get, the result of this function will actually return a dataset, which is a structure that behaves like Clojure map. Just a regular Clojure map. And if we want to do that in Clojure, that's the way it's done. And now you can say, well, Mey, that's not so bad. It's just 3 lines compared to 1 line. That's not really bad. But wait, what you get back from using Reader is not a Clojure map. In order to get a Clojure map, and when I say Clojure map, I mean like the good old key values map. That's what you'll have to do. So you need to create an extra function to convert a vector of vectors into a vector of maps. Just the comment sounds kind of annoying, to be honest, but that's the way it is. So this is the first example, and see how short and fun and intuitive this dataset function in Tablecloth. I don't know, I loved it. So the next example that I think is pretty common for, in our everyday usage is finding the shortest something. Here, it's finding the shortest Pokemon. Oh, and I have to say this. Did you notice how I called it Code Wars. I was like, wink, wink, Star Wars, but it's still Pokemon themed. Okay, yeah, I thought it sounded funnier when I prepared the presentation, but okay. So let's see the example of how we can find the shortest Pokemon using Tablecloth. So the first thing that we do in this function is we use a thread first and macro, and then we send the Pokemon file path. It goes right into the data set, and the result of that will go into the select columns. Now, by the way, when I say TC, I mean Tablecloth. I just didn't insert the import here, just a safe space. So Tablecloth, select columns. As you can see, you can put the names of the columns as keywords, and this is how you will get the relevant columns that you want. And last, order by, pretty straightforward. What do I want to order by? It's the height. That's it, done. 3-4 lines of code, amazing. This is the amount of code that I had to use in order to do the same thing with just Clojure. And again, maybe you can do it a bit better, maybe you can do it a lot better, but still, compared with just those 3 functions that I got out of the box with Tablecloth, that's pretty amazing. Now, what will happen if I run this code into the REPL? The first thing that I want you all to notice is how beautifully this is printed to the REPL. I didn't need to use extra print function or anything like that. It's just being printed beautiful the way you see it over here. And the next thing that I want you to notice is there are empty values. Now, I chose to go with the default behavior of Tablecloth and just get those values as nil or 0. But if you want to do specific, if you want to do some other strategy for handling missing values, you can do that with any of those 3 functions that I listed over here in Tablecloth. You can do the select missing, you can do drop missing, maybe replace it with something else. So there you have it. Now, do you want to know what happened when I ran the Clojure code into the REPL? Yep, I got an error. And this error is because I had empty strings and I didn't handle that in my Clojure code. Now, okay, I think that you maybe kind of got the idea of the comparison between, just Clojure with Tablecloth code. And I just want to do another example with just Tablecloth, just so I can show you a few more actions that you can take with Tablecloth that are not as simple as what I showed you just now. So I decided that I want to find my matching Pokemon. And when I say my matching Pokemon, I mean by my height and weight. And I wanted to know how many wins this Pokemon had. So this is the code. Now, don't panic. We'll go through line by line. But before we do that, this is the import that I promised you. So when I say TC in this code, you remember that it's just the Tablecloth API. So let's go line by line. So in my Pokemon total win count, what we use to get the number of wins of a specific Pokemon is the Pokemon total wins count. So this is this def that we have right there in line number 1. So let's see what happens there. So in Pokemon total wins count, what we will be getting is a data set with 2 columns. One column will have the number of wins, and the other column will have the Pokédex ID of the Pokemon that we wanted. So the first step that we will do, you have it again, the dataset function that takes the Pokemon Combats file path. Then what we do is group by, and over here we group by winner, and winner is the Pokédex ID of the winner Pokemon. And this is in order to have all of the lines that have a specific Pokédex ID grouped together. We use that in the next line, which is aggregate. And this is where we actually do the counting of how many lines of winnings this specific Pokemon had in each group. The last part of this def is rename columns. Now, the reason that I did that was because later on in line number 12, I am going to do a left join. And left join is being done by matching columns by their name. So in the combats table, the winner column was named winner. So I renamed it to Pokédex ID, so it will be easier for me to do the left join later on in line number 12. So now that we have you remember, we have two columns, one with the Pokédex ID, and the other has the total number of wins for each Pokemon. Let's see how many wins my Pokemon had. So again, we start by loading the Pokemon file, the Pokemon CSV file into a dataset. And then we have the select columns, in which we select 4 columns. We select the Pokédex ID, name, height, and weight. And then we have lines 10 and 11, where we do select rows. Now, what I do over here, I filter these rows with the predicate that you see over here in line number 11. And I ask, just by, is it my weight and my height? And this is the way I chose to do the filter. And then we have the left join that I talked about. This is in order to connect the two data sets, the one with all of the Pokemon data and the one with the total number of wins. We have order by, the amount of wins. And again, select columns, because we just don't need all of them. We just need these columns to be presented as the result. So are you hyped to see what Pokemon that matches my height and weight has the most wins, or not most wins, how many wins this Pokemon has? Okay. And ta-da, it's Hitmonchan. It's this, I think it's like super cute. I know I make myself laugh, but okay. I love the fact that like it has like the boxing gloves, but also the skirt. I kind of dig this vibe. So later on, I was curious which Pokemon has the most wins, and it's Hoot Hoot, which I don't know. I find it weird. I wouldn't bet on this to be the Pokemon with the most wins, but I'm not going to argue. Let's move forward to the real deal of this of this presentation. So now that we've seen how beautiful it is to write, data manipulation using Tablecloth. If that didn't convince you enough to start using Tablecloth today, tomorrow, yesterday, so if that did not convince you, let me try to show you the real magic behind Tablecloth. And I'm going to do that by doing a deep dive with some code examples. So what we're going to look at are 3 structures that you're going to find when you start using Tablecloth. You will use the data set, you will use row, and you will use a column. So when you start with Tablecloth, I think you're already familiar with this, strip of code. You will see the data set, Pokemon file path. You already know it. And we want to know, what is this data set structure? What is this? And that's what it is. Dataset is a special type which can be considered as a map of columns implemented around TechML data type library. So when I say a map of columns, does it mean that I can just refer to each column as a map? Let's see. So what is a data set? Over here, you can see that I defined the Pokemon DS. I use the get Pokemon DS function. And if I send it to the repo, we will just see the Pokemon dataset printed. Now, remember how I said that you don't need a print function and it's just printed out beautifully the way it is? That's it. You see, all of the columns are well ordered, and it's, the spaces are really nice, and it's super easy to look at it when you're working. Also, you can see the amount of lines and columns mentioned up here. And then I'm going to ask, so wait a minute, what did we say about dataset? Is it a map? So, yeah, true. That's a map. So what are the keys of this map? That's interesting. And I guess that you can kind of guess it because that's very intuitive. And yeah, you guessed it. The columns, the keys are the columns names. But notice this, each and every one of those is actually a keyword, which means that yes, you can use them as just normal keywords in every Clojure map. And the values obviously will be just the values of each column. And I want you to notice that what you see over here is that each column holds the values as the basic types, like string, like int, and this is very efficient in terms of memory usage. There isn't like a very special object or something. It's just those basic types. So we can approach the data of a single column with a keyword. Yes, we can do that. So if I jump a little bit ahead, if I use the Pokédex number with the Pokemon DS dataset, then yeah, we got the column of the Pokédex number with all of its values. Now, this is pretty cool, but I promise that I'm going to show you what's behind that, not just a few simple code examples. So let's do just that. Because when I said that it's a map of columns, it's not really a map, just simple map of columns. It can be considered as. And I want to make this a little sharper. What does it really mean that it can be considered as? It means that there is a whole lot of things going, happening under the hood. So if we go directly to the Tabular dataset repo and we go to the dataset CLJ, we can see over here that the def type dataset is actually implementing Java util among other implementations that we have down there. Now this code is pretty long, so you can now understand that the beauty that we get, for as a user, as a developer, I get to use dataset as just a map. But the flexibility comes from having implementation of several other Java interfaces and Clojure protocols. So if we move forward to column deep dive, what we will see is that each column can be considered, remember the considered as again, named sequence of typed data. So if we go to the same place that we found the dataset CLJ, we will see column CLJ. And if we go over there, surprise, you will see that the def type of column is actually, it actually has a P2 array buffer. Now, here's the thing. When I said named sequence, maybe some of you thought, wait, like lazy sequence, like regular sequence? And the thing is that, and nothing here is just simple sequence or just simple map, because the efficiency comes from the usage of this array buffer. And let's see the example. So we will get it, just right in front of our eyes. So what I'm going to do over here is I'm going to create a big data set, which is constructed of 2 columns with 100 million rows. And you can see how fast this being loaded. I typed big column and it just brought back 100 million rows in mere seconds. And then what you can see is also that I asked for the 1 million row, and which also happened pretty quick. Now, in the last example, you can see that what I did is I used Func in order to multiply by 3 all of the rows in big column. And then I wanted to add 1 to all of the rows of big column. And then I just wanted the 1 million row. But here's the thing. If I would use lazy sequence, I would need to make 1 million computations, because it will do all of the computations until the actual value that needs to be returned. In dtype next buffer, the only thing that was computed was multiply by 3 plus 1 once for the 1 value that I needed. Another cool thing that contributes to the high efficiency of this library is that it's lazy and non-caching. And when I say non-caching, by simple words, it's just not remembering anything. Now, sometimes it's good to have values that we already calculated to be remembered, to be cached, but it's not always like that. For example, if we do some image processing and we have a long pipeline of processing operations, then we maybe do some computation on one slice of the image. We don't really need to have this slice that was computed already saved because it's going down the line. So I think that's the beauty of lazy and non-caching. So let's move forward. And we got to the last part. We will talk about row deep dive, and there isn't a lot to say about this. I just wanted you to notice over here, again, you can see how I just dived into the TechML dataset, and I went straight to the do select rows. And what I found over there is that I, like in line number 400, it does select dataset or column all row indexes. And then I was like, wait a minute. So a row is a column or a map? Let's see for ourselves with this last small example that we have for today. So again, we still use the 100 million lines data set that I created. And over here, you can see that the first thing that I did was I asked to get the three first lines as three first rows as maps. And what you can see is that it actually returned a map where the column name was just injected with the row value. And this way I can send these maps down the pipeline for other functions that are expecting, to get more of these internal maps in the big array that I have, or the big collection, not array. So that's pretty useful. And the next thing that I want to check out is this example. So over here, what I show you is me asking if this a map, like is a row, is it a map? I get true. But then when I ask for the type, we will see that we get a special type called fast struct, which is what enables us as users, again, developers, see rows as maps, but it's actually stored in columns. So yeah, rows are both, they can be considered as maps, but they are actually stored in columns, and it's special maps of type fast struct. So I can say we dived like pretty deep, but not that deep. If it's not deep enough for you, I invite you to dive even deeper with the Clojure study groups and, go find new things and learn more about Tablecloth and about TechML dataset. And you get to do that with great, great people. And if you want to join them, just scan this QR code and join the party. I'm telling you, you'll have a great time. If you ask yourself, okay, Mey, or I said, if you ask yourself, okay, Mey, but I guess you got the point. If you ask, what else can I do with Tablecloth? So, ta-da, that's the link to my previous talk about Tablecloth. And again, the QR code will take you there, and you will see in this talk that I go line by line with code examples of different functions that I found in the Tablecloth documentation. I just explained them and how to use them. And all links and code examples, they all can be found here in my GitHub or in the QR code if you manage to scan it. And we're almost done. But there is one thing that I have to do before you go. Are you all ready for this? I hope you are. I want to give big thanks to Daniel Slutsky, first of all, for being an amazing friend. But also, I want to say big thanks to Daniel Slutsky for helping me with this presentation, with the code examples, with thinking about how we can do this the best way possible to prove the world how beautiful and amazing Tablecloth is. And now is an amazing time to end this presentation and say thank you for watching and listening. Is this slide overwhelming? Yes, but I saved it for the end, so that's okay. All of these Pokemon, it's just the last slide. Thank you.
Thank you very much, Mey. Thank you very much. And to all our viewers, we have some issues with the sound, hence we've had some, it's like on our end. So we'll soon head over to Michael and his next presentation. Hence we can't do a Q&A because we have some issues with the sound here in the studio. And sorry for that. Again, thank you very much, Mey. There are big applause. People are shouting and cheering in the YouTube chat. Very well done. I think it was a very interesting presentation. I also would like to say that I've myself is pretty old, so I also only know the first generation of Pokémons, and I started watching Pokémon again with my kids, and we only got to the first generation.